Hello everyone, my name is Óbuda and this is my unofficial network state exam solution. Now it's the 29th topic, which is about the protection of the traffic traversing public networks. And the first bullet point is the main components of network security. So here we have to talk about the whole network, because until this topic we talk about some stuffs, but the important is coming here, because we have to, or we can have several security approaches to secure our network. Of course, the first approach is to implementing intrusion prevention detection systems, firewalls, traffic filtering approaches like access control lists. So with these devices or approaches, we can make more secure our network or networks. But now we just talking about devices that helps you ensure the traffic or to secure the traffic that goes through. But the main component, or what the really important, that we have to also ensure in a other way. So we have to ensure that the traffic should not be captured, or if it has been captured, then nobody should be able to see it, or we should somehow know that if we get the data, then that is getting from the guy that's saying that the guy is saying that sent to us. So now we have talked about security devices that helps to transmit and receive data on the network in a secure way, but now we are actually caring about the traffic itself that should be somehow managed in order to get to us. So the main components of the network security really now is the CIA approach, the confidentiality, integrity, and authentication or authenticity. I don't know what's the exact spelling of it. So of course, if I remember well, either authentication or authenticity should ensure that if you receive a packet, then it should be received by a guy who is saying that sent us to the message, and not by another guy who manipulated the message, for example. The integrity is important, that it should ensure that the traffic will not be captured during transmission. And the confidentiality is there, that even if the traffic has been captured during the transmission, then it should not be able to see by others, but only the actual receiver should see the actual traffic. So that's the main component. The purposes and goals of the hashing algorithm. If I remember well, the hashing algorithm helps the integrity and also the authentication. Because how this looks like, we are having hashing. So imagine that this is our plain text. This will be a hashing function, and as a result we'll get a hash. So here we have a hash function. This will be the plain text, and the result will be a hashed plain text. So the really big advantage of the hashing is that we are using or doing a one-way coding or one-way hashing. That simply means that the plain text will be converted to something that will have a smaller length, but that cannot be retrieved, or we cannot convert back to get the actual data. So this is used to actually verify the integrity of the data. Because how does it look like? It's similar like the CRC when we are talking about the trailer at the data link layer and the error correction like the parity bit. Because imagine that we have exactly the same. So how does it look like? for example, host A will use a plain text, will hash it through a hash function, will generate a message, and this will be sent to another host, where the other host will simply checks the plain text, will use the same hashing function that the other guy used, and if we'll do the hash with the plain text and the two hash results will be exactly the same, then this means that nothing happened to the actual data, so it's good. It has not been manipulated. So that's the aim of hashing, and it's important that if one bit in the plain text has been changed, then the hashing function will be different. So that's the advantage of it, and that's why we are using it. So this is the approach to verify the integrity, and as I said, it also verifies the authentication if the user adds its key to the plain text, because how does it look like if it adds its key to the plain text and will hash it, then it will verify on the other side, then it will be received by a guy who is having its key, because nobody else could have that key, therefore it simply ensures and verifies the guy. That's why it's also used as authentication. In that case, if I remember right, it's KH, how it's spelled? Key. So if I remember, it's key hashing algorithm message something code, key hashing algorithm message code or something. Yeah, something like that, its name. Okay, the purposes and goals of authentication, the operations of different algorithms. This was the purposes and goals of the authentication, that we are adding to the plaintext our key as well. Therefore, we are ensuring. Okay. The purposes and goals of encryption, symmetric, asymmetric solution, the operations of different algorithms. So this is totally new, or not something like that. Okay, so it's something else. So the encryption, as I said, if the package or the traffic has been captured, then we somehow have to ensure that the package cannot be readable by anyone else. So that's why we are using encryption. Of course, here you can come up with the old ones like the Caesar, because at encryption we are usually using transposition, substitution, or block ciphering. So that simply means that at substitution we are changing, for example, the alphabet to another, like the Caesar. At the transposition we are repositioning for example, the password several times to have something else, but on the other side the user will have to retranspose it to get the exact solution. So the approach of encryption that I've just said now, that the other side somehow has to know how to decipher or have to decrypt it, and that's why they will need to share a key. We have a symmetric approach like the Caesar approach, where the plain text has been encrypted with a key, and with the exactly same key it could be decrypted as well. So that's the simple solution, that with the symmetric approach we are using the same key for encryption and decryption as well. The asymmetric solution, of course, a bit more important or a bit better, because the disadvantage of symmetric solution, that somehow these people have to share the key between each other, and the key space and the key length cannot be that much, because then it's harder to decrypt and it can be time consuming. So that's the problem with the symmetric. At the asymmetric we are having two keys, a public and a private. The public can be get by anyone, and the private is always with us. So the idea with this that with the help of the Diffie-Hellman key exchange solution, we can exchange keys over the internet, and simply we don't have to meet in real life to actually change the key, so it's a bit more secure. In this case, what's going to happen, let's say that we have the plain text. Okay, we have, I don't know, we have here a key, we have an encrypted text, we have another key, and the last one. So what's going to happen? We would like to send here, usually it's called A or it's Bob, usually Bob, we are sending message to Bob. So how does it look like? As I said, Bob has a public and a private. I will say P and P are like private. So if we would like to send from Lily, here we have Lily, and if Lily would like to send a message to Bob, then Lily will get Bob's public key, will write the plain text, will encrypt it with Bob public key, so then we will get a encrypted message. Then it will be passed to Bob. Bob will see the encrypted text. Bob will use its own private key to decrypt. Will use its own private key to decrypt and get the actual plain text. So basically that's the difference, that here we are using two keys and we are always encrypting with the other's public key here and decrypting with our private key. That's really important, and basically that's the difference, because on the other end, if we are not using this, on the other end this would be just simply using this. There is the plain text, it is encrypted with the public key. There is the encrypted message, and it is decrypted with the same public key. So that's the symmetry. So you can see that that's the difference, and of course it is more secure to using this approach. For example, because it asks like operation of different algorithms. If I remember well, here is the dash or the 3-dash algorithm. For example, the 3-dash using a symmetric approach, because it first encrypt the message, then decrypt, then encrypt again, because here we are using 3 different keys. If I remember, I don't know which, 64 bits or something like that. So we first encrypt with the first key, then decrypt, then the second, and then encrypt with the third one. So that's basically, and if we would like to decrypt, we have to do exactly the same. First decrypt, then encrypt, then decrypt. So that's the symmetric solution, for example. For asymmetric, I don't know exact solution or algorithm, so then please check for it, because I didn't look for it too much. Purposes and goals of integrity, the operation of different algorithms. I already talked about this. This is the hashing algorithm, and here is the MD5 if I remember well, and the SHA. Purposes and goals of key management, the operation of different algorithms. Here it is quite simple that I've said that we have a key length and the key space. The key length simply determines how long the key. Of course, the longer the better, because it's harder to decrypt. And the key space is visualizing that how many available or how many possibilities and how much approaches it needs for example, a brute force attack to be decrypted. So of course the simplest solution is, if we are using 2 bits, then it's 2 approaches. If we are using 3 bits, then we double it. So if we're using more bits, then we will again increase it. So what's going to happen is of course that's not for, we are just improving the previous ones, and this is not to, we are just saying that we are going to improve the key space, so we are going to make it harder, because if the key space is big enough or long enough, then there are times when the attacker is wasting its time because it needs like 10 years to decrypt the password, and for example, after 10 years he will get the message that oops, the password has been changed. So it is really, really good to have. Of course, the other key exchange, as I said, the diffiam on the key exchange, and I believe that's all. The sharing it, and that's all. The digital signatures, public key infrastructure, certification-based operation. I don't know actually about this. The digital signature verifies that something, for example, you downloading something from a website, then there is a certification that it has been downloaded, for example, from Microsoft, therefore it is a valid one. So in this case, the digital signature means that we are guaranteed that it will be a good one, and it is verified by an infrastructure from a third party who will ensure that this digital signature is good. And that's all about it. I here skipped some stuff, so please check for them. Mainly I covered everything, but I skipped some stuff because at the end I skipped some bullet points in order to learn other stuff. So I believe it's enough for at least I believe a good, but at least for an average. So again, if I said something wrong, then I don't really care, and don't forget to subscribe.